On today's episode, precise, accurate aircraft navigation without GPS. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Navigation has always been a fundamental part of any transportation system. Ancient mariners learned how to use the stars and sun to set a course, and the advent of the chronometer added longitude and latitude measurement and made true precision navigation at sea possible. Early aviators often read the names of towns from water towers and grain elevators, using highway maps for reference. But by the advent of mainline commercial aviation in the 1930s, navigation of aircraft became the job of a specially trained individual, using celestial navigation and radio aids that required significant ground-based infrastructure. Now, devices do exist that operate without external beacons, such as inertial navigation systems, but they're expensive, complex, and are generally reserved for high-end military and a few commercial applications. Satellite navigation systems, however, changed everything. The first was the U.S. Global Positioning System, initially developed for military use, but today there are multiple sat-nav systems, from the Russian GLONASS system, China's Baidu, and the European Union's Galileo. Both Japan and India plan to introduce similar systems as well. These systems use constellations of 18 to 30 satellites that transmit orbital data and a timing signal. With a suitable receiver, it's possible to compare the time of broadcast encoded in the satellite transmissions to calculate time of flight and determine longitude and latitude, as well as altitude. So it's perfect for aviation use, but sat-nav systems are derived from military systems, and they're used to deliver ordnance on target, as well as aid in navigation. In time of war, it's widely expected that sat-nav systems will be jammed or even disabled, with serious implications for civilian users and commercial aviation. Honeywell Aerospace has demonstrated a suite of technologies which can work for precise aircraft navigation without GPS or external radio references. Termed alternative navigation technologies, the Honeywell test used three separate systems. Vision-aided navigation uses a live camera feed and compares the images to stored maps as a reference, while a celestial-aided navigation system tracks stars as well as known satellites as an alternative, passive, and non-jammable solution. Now, Honeywell claims an accuracy of 25 meters with a circular error probability of 50%. The third technology is unique, magnetic anomaly-aided navigation. The Honeywell test was the first time that this technology has been used on aircraft, using measurements of the Earth's magnetic field strength and comparing them to magnetic maps to accurately identify position. The test aircraft, an Embraer E-170 regional jetliner, also included a conventional inertial navigation system with a GPS anti-jamming device. GPS-like position reporting without satellites? It now appears to be technically possible without the high cost and alignment issues of inertial navigation systems. The company expects that the combination of GPS enhancements to defeat jamming and multiple alternate technologies that don't rely on external sources can be combined into prototype systems this year, with deliveries expected to start of production units in 2023. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.